Hello everyone, welcome you all in the another lecture of Structural Analysis 1. Myself, Mr. Aasif Baig, Assistant Professor, Civil Engineering Department, Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur. So friends, today we will see the overhang beam to the beam continuous beam structure, and we will analyze this beam with the three moment theorem. So for the basic information of this three moment theorem, which is also called as Clapeyron's theorem, the link is given in the description of this video. You can go through it and you can get the clear idea about the three moment theorem. So this is the extension of the numerical which we have taken in the earlier class. Okay, so what I have taken the same numerical which I have taken in the previous class, and I have made one overhang element to the D support. Okay, so this overhang beam is nothing but a member, but it is a part of determinate structure. So by this overhang portion will create the moment of 10 kN with this distance 2 meter. So the moment will be created in the clockwise direction of 20 kN. Okay, and to sustain this or to counterpart this 20 kN UDL, 20 kN moment, support D will be acting in anti-clockwise direction with having the same magnitude. So at D, the moment will be minus 20 kN. So as here, the moment D will not be unknown to us or will not be zero here. The moment will be minus 20 kN. So what will be the changes due to this overhang portion we will see in this numerical. So as per our protocol, we will first draw the bending moment diagram of this respective beam. So here AB portion, AB beam is consists of 100 kN eccentric load at a distance of 1 meter from A and 3 meter from B, having moment of inertia I. Then moment B, member BC, that is beam BC, is carrying 40 kN per meter UDL over the span of 4 meter, having moment of inertia 2I. Then member CD is subjected to eccentric point load of 80 kN, 2 meter from D and 3 meter from C, having moment of inertia 1.5I. And one overhang portion is there of having 10 kN point load at the end of span 2 meter. Okay, so we will draw first the bending moment diagram. So bending moment diagram for this eccentric point load will be WAB by L. So if you enter the value of this 100 kN at W, and A value is 1 meter, B is 3 meter, divided by L is 4 meter. So the value will be equals to 75. So we will draw this in first degree curve. So moment will be 75 kN. Then BC span carrying 40 kN per meter UDL. So this is calculated as WL square by 8, where W is 40, L is 4. So the value is equals to 80 kN. So this is 80 kN. Then the third portion is CD. Third beam is CD, which is consists of eccentric point load. So the equation will be again same, WAB by L, where A is 3 meter, B is 2 meter, and W is 80 kN. So the moment will be equals to 96 kN. 96 kN. I am writing it. Okay, so this is now visible to you, I think. So 96 kN. And one more additional moment will be there. This moment is not a free bending moment. This is a support bending moment. So due to this overhang portion, one additional load is acting over there, 10 kN load over the span of 2 meters. So 20 kN clockwise moment will be acting over this support D. So the moment D will be equals to minus 20. So this moment D we already know, minus 20 kN. So while applying the three moment theorem, and when we will consider this BC and CD span, and we will apply three moment theorem on these two span, we have to consider minus 20 kilonewton meter at MD. Okay, so we are not keeping this moment as unknown. This moment is known to us. So directly we will apply three moment theorem. So as we have discussed earlier, we have to first consider this first two span. We will apply three moment theorem to span A, B, C, and one equation will form. Then we will apply the three moment theorem over the span B, C, D. Then another equation will be applied, will be generated, and in that equation two unknown will be there. Moment B will be unknown there, and moment C will be unknown there. Moment A will be 0 because it is air support, and moment D will be having the value of minus 20 kilonewton meter, which is we are writing directly over there. Okay, so this is not unknown and this is not 0. So we are writing this minus 20 kilonewton meter directly over there due to this overhang portion. Okay, so we will apply this three moment theorem on span A, B, C. So three moment theorem is MA L1 by I1 plus twice MB L1 by I1 plus L2 by I2 plus MC L2 by I2 is equals to minus 6 A1 x1 bar divided by L1 I1 minus 6 A2 x2 bar divided by L2 I2. So as we are applying three moment theorem over the span ABC, so we will draw the bending moment diagram of ABC beam for the ease of the calculation. So this is what 75 kilonewton meter, and this is this should be greater than this 75, so this is like this. So this is 80 kilonewton meter. So this is the first bending moment diagram, this is second bending moment diagram. So area of first bending moment diagram is half base into height, and area of second bending moment diagram is 2/3 base into height, where height we know, base we know. Okay, so from this we can calculate. This is 4 meter, this is 4 meter, so we can calculate area 1 and area 2 directly. This is what the center of gravity of the first bending moment diagram from left hand side, and this is the center of gravity of the second bending moment diagram from right hand side. So that value we have to calculate. So we will calculate one by one. First, area 1 is half base into height, where base is 4 and height is 75, so it is equals to 150 kilonewton meter. Then area 2 will be 2/3 base into height, so this is 2/3 base is 4 into height is 80, so the calculation of this is 213.33, this is kilonewton meter square, 33 kilonewton meter square. Then another value is x1 bar. So x1 bar is this is unsymmetry triangle. So this is L plus A by 3. L is 4 plus A is 1 divided by 3. So 5 by 3. This is 1.67 meter. And value of x2, which is from the right hand side, because we are calculating x2 of the second bending moment diagram. So x2 is, due to the symmetry, this will be L by 2. So L is 4 by 2, that is 2 meters. So by putting this value in this equation, where the value of MA will be 0, MB will be unknown, MC will be unknown, and the rest of the value we know, we have calculated. So we will put that value directly. So this is 2 MB, value of L1 is 4 divided by I1 is I, plus value of L2 is 4 divided by 2I, plus MC is equals to L2 is 4 divided by I2 is 2I, is equals to minus 6 A1 is 150 into 1.67 x1 bar divided by I1 and L1. So L1 is 4 and I1 is I. Minus 6 into A2 is 213.33 into x2 is 2 meter divided by 4 into 2I. So if you calculate all this value, I will remain on the both sides, and if you divide that value with the I, so this I will get cancelled. So only we have to cancel this I, and the remaining thing which we have to calculate, which will be in the form of MB and MC. So the rest equation we have to calculate directly. So I am writing that equation directly at this point. Okay. So the equation will be equals to 12 MB plus 2 MC is equals to minus 695.75. So this is the equation number 1. This is the same thing which we have calculated in the previous class. What is addition here? This is overhang portion. So this calculation will reflect when we apply 3 moment theorem for the span of BCD. Okay. So at the moment of MD we have to put this minus 20 km/meter. So only the change will be over there. So and for the ease of understanding, I am taking the same numerical. And I have provided overhang portion to that. Okay. So this thing will be same which we have calculated in the previous class. 12 MB plus 2 MC is equals to minus 695.75. And this equation we have to take while calculating the moment MB and MC. This is equation number 1. When we will apply 3 moment theorem over the span BCD, we will get the second equation. We will equate both the equations. We will get moment MB and MC. Now we will apply 3 moment theorem over the span BCD. So this is, we are drawing the bending moment diagram of BCD. So this is 96, this is 80. Now the area of this bending moment diagram will be considered as A1 and this one is A2. This is now x1 bar, this is x2 bar. Okay. So we are applying 3 moment theorem. I am writing 3 moment theorem. So MB L1 by I1, where L1 will be now this 4 meter and I1 will be 2I plus twice MC L1 by I1 plus L2 by I2 plus MD L2 by I2 is equals to minus 6 A1 x1 bar divided by I1 L1 minus 6 A2 x2 bar divided by L2 I2. Now the value of A1 x1 bar, A2 x2 bar we have to calculate. So A1 is, that is parabolic shape, so this is 2/3 of B into H. B we know 4 meter, H we know 80. So this is 213.33 kilonewton meter. Now A2 is half base into height. We know base is 5 meter and height is 96. So this is 240 kilonewton meter. So x1 is L by 2 into the symmetry. So this is L by 2, that is 4 by 2. 2 meter, and this is x2 bar from right hand side. So L plus x2 bar, L plus B by 3, 5 plus B is 2 meter. So 5 plus 2 divided by 3, 5 plus 2 by 3, that is, the value is 2.33 meter. So when we put this value into this equation, we have to remember that MB is unknown, MC is unknown, and MB is having value minus 20 km/meter. We will put all this value of A1 x1 bar, A2 x2 bar, and we will calculate there is equation number 2. So MB into L1 is 4 divided by 2y plus twice MC. L1 is 4 divided by 2y plus 5 divided by 1.5i plus MD. MD is minus 20, so this plus sign will not be there. So this is minus 20 into 5 divided by 1.5i is equals to minus 6. A1 is 213.33 into 2 divided by L1 is 4 divided by 2y minus 6 into A2 is 240 into 2.33 divided by this 5 into 1.5i. So when we will calculate all these values, this value will be unknown, this value will be unknown, this is known to us, so this is minus 20 divided into 5 by 1.5. First we will cancel this I value from both the sides, and we will then calculate this value. We will take to the another side of the equal. So this will be plus 20 into 5 by 1.5 will add in this equation. Okay. So whatever will be the calculation that I am writing directly over here. So we are getting after the calculation equation number 2. So the equation we are getting is 2md plus 10.67 mc is equals to minus 700.68. So this is what the equation number 2. Now we will equate this equation number 2 with the previous equation number 1, and we will get this value MB and MC. So directly I am writing MB and MC value. Now from the equation number 1 and equation number 2, if we equate equation 1 and equation 2, you will get the value of unknown MB and MC as minus 48.55 kilonewton meter and minus 56.56 kilonewton meter. Now MD value, which is minus 20 kilonewton meter, it is directly given to us. So this is minus 20 kilonewton meter. Now this is time to draw the final bending moment diagram. So for final bending moment diagram, we will first draw the free bending moment diagram. So this is free bending moment diagram. This is 75, this is 80, and this is 96 kilonewton meter. And value of MA is 0. Value of MB is minus 48.55. So due to this minus, we are drawing the support bending moment diagram above the line. Okay, so many of the people will think that why it is we are drawing the positive bending moment diagram as well as negative bending moment diagram above the line. So these bending moment diagrams are different to each other. So the positive bending moment diagram we always draw above the line, but when we are talking about the support bending moment diagram, we draw that bending moment according to their rotation, their side. Okay, so as the sign is negative, this will rotate in the anti-clockwise direction, and due to that we are drawing that bending moment diagram above the line, and if the bending moment diagram is positive, we are drawing that line below the line. Okay, diagram below the line. Okay, now bending moment diagram MB is minus 48.55, so 48.55 we are drawing this, we are connecting this. This is 48.55. Now bending moment diagram C is minus 56.56, so this is 56.56, we are drawing this 56.56. Now this is bending moment diagram D, so this is not 0 over here. Okay, this is minus 20 kilonewton meter, so this we have to draw minus 20 kilonewton meter, and after that at this hinge point we are drawing this 0. So this portion is the overhang portion, and this portion having the moment 20 kilonewton meter. Okay, so this is what the final bending moment diagram. So whatever remain in this diagram, that we call as net bending moment. So this remain as the positive bending moment diagram. This portion remain as the negative bending moment diagram. This is the positive bending moment diagram. This is negative bending moment diagram. This is what the positive one, and this is what the negative one. So whatever the vertical line I am drawing here, that all are the net positive bending moment, and these are the net negative bending moment. Okay, and looking into this positive and negative bending moment, we proceed for the design. Okay, so this is what the end of this analysis of 3 consecutive beam consists of one overhang portion by 3 moment theorem. So friends, we have learned 3 consecutive beam, the analysis of that with Clapeyron's theorem. In the next lecture, we will see what will happen or how to calculate the 4 if the beam is having a 4 span. Okay, so in that case, the 4 span having 3 unknowns, and we have to apply 3 moment theorem 3 times. Okay, and we will form 3 equations. We will equate the 3 equations. We will calculate the 3 unknowns from the 3 equations. Okay, so this is why this theorem is called as 3 moment theorem, because we can easily determine the 3 unknowns of the beam, indeterminate beam. If you have to calculate the 4 unknowns from this equation, this may goes difficult while calculating the unknown moments. Okay, we can calculate that moment, but that goes difficult calculation. Okay, that's why the new methods of the new compatibility equation is introduced, and this is restricted to the 3 moment calculation. That's why this moment Clapeyron's theorem is called as 3 moment theorem. Okay, thank you very much.